Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own Mars Coder this side. So in this video we're going to start with the traversals of the binary tree. So I hope you will like the video. Okay, so as we discussed in the last video, there are many types of traversals of the linked list or of the binary tree, right? It can be left, root, right? It can be left, root, right. It can be left, right, root, left, right, root, right? And there are many more. There are many more, right? So we're going to get a glimpse of what are traversals, right? So there are, let's say, 5 types of traversals. What is the first one? First one of them, and the most easiest one, is pre-order traversal. Pre-order traversal, right? After that comes in order is post-order traversal. Post-order traversal. Beginning with in-order traversal, followed by level order traversal, and then vertical order traversal. Vertical order traversal. These are the 5 types of traversals. There can be many more. Any combination can be made, like zigzag order, diagonal order, anything. But these are the 5 basic types of thing that you will have to learn about traversal. And if you are fluent with these 5, you can handle any type of traversal. And also, if you are able to handle these 5 types of traversal, you can solve any question of the binary tree, because all the binary tree questions are actually solved by traversals only, which are of good level, are actually solved by uh, traversals only, right? So let us move with it. So in this video, we're going to discuss the pre-order traversal, followed by all the videos will come, like next video will be for post order, then for in order, then for level, then for vertical, right? So follow them in order. So talk about pre-order traversal. Talk about pre-order traversal. What is pre-order traversal? What is pre-order traversal? So suppose I make a binary tree as 1 connected to 2, 3 here, 4 here, 5 here, 6 here, and 7 here, right? This is my binary tree. Now what do I mean by pre-order traversal? So pre-order traversal means explore your root first, followed by your left child, followed by your right child, right? The pre-order is root, left, right. Root, then left, then right. What do I mean by that? That first, if I try to write the traversal into, if I try to print the traversal, then I will be printing the root first. So what is the root here? This is this one. So I will be printing 1 here. After that, left. So I will move towards the left. So I will be printing out 2. 2 is left now. 4. Now, 4 is explored, there is no left of 4, there is no right of 4, I will move back to 2. After moving back to 2, I will see that 2 has a right child which is unexplored right now. So I move towards right. Again, 5 is the root now, so I will be printing 5. 5 doesn't have any left, 5 doesn't have any right. Moving back to 2. 2's left and right are explored. Moving back to 1. 1 left is explored, but 1 right is still unexplored. I will be moving to 3. Treat 3 as root, print 3. Moving towards the 3's left, 6. 6 doesn't have a left, 6 doesn't have a right. Move back to 3. 3 has the 6, but it has explored. 3 has a right also, still unexplored. Moving towards 7. Print 7. 7 doesn't have a left, 7 doesn't have a right. 7 will go towards 3. 3 will go towards 1. And 1 will say that my left is also explored, my right is also explored, and I can just simply return out. So your pre-order traversal will look something like this. 1, 2, 4, 5, 3, 6, 7. 1, 2, 4, 5, 3, 6, 7 of the given binary tree. Now, when I was studying the pre-order traversal, I was like very much confused. I was very much confused until I learned a hack from YouTube. Which helps me in every traversal, right? So let's discuss about the pre-order. How can we use the hack on pre-order? So my hack says that for pre-order, on the left side of node, put a line like this. For each side, each node, put a line like this. On the left side, make sure to put it on the left side. You put it, right? Now, take a pen and start from this direction only, from the left side, and go towards the, like, follow the boundary of the tree, right? So if I'm following the boundary of the tree, as soon as I intersect any line, that means that node is in the correct position. So 1, moving on, 2, moving on, 4, like this, and now 5, and now 3, 6 now, 7. and I can see that all the lines are intersected, all the nodes are listed down. So I will stop my preorder traversal, and you can see that both these traversals are actually matching 1 2 4 5 3 6 7. So this is a hack. What is the hack? Let me write it down. Put a line on each node on on left side, and start traversing boundary from left only, right? This is the only hack you need to know about the pre-order traversal. Stay tuned with the playlist and you will get the same hack for in order for the post order as well, right? Okay, now moving on how to write the code for pre-order. Like, you want to get the code for pre-order, you want to print the pre-order on your terminal as well. How will you do it? So let us move towards the code. So pre-order traversal, there are two ways to write down the traversal. One is a recursive way, which is damn easy, and one is the iterative way, which is also easy, but you will have to understand it first. Okay, so let us explore the easier one first. That is recursive. What do I do in recursive code of pre-order, right? So for the given tree, 1 2 3 4 5 6 7, right? 1 2 3 4 5 6 7. Suppose this is my root, this is passed to me as my root. What will I do? I will create a helper function that will be helping me in printing. So helper, what will it take as an argument? It will take the root as an argument. Now for this case, when I will be calling, like, what I'm saying is, if root is not equals to null, then there is something to explore, right? Now what does preorder say? Explore this and move towards left, and after that move towards right. What does it say? Explore, move towards left, then towards right, then towards right. I will be doing the same. Explore. What do I mean by explore here? I want to print. So what do I say? Print. What do I print? Let's say printing the root's value. Print root value. What will it print? It will print 1, right? After that, I am saying move towards left. How will I move towards left? I will use recursion here. What do I say? I will say call the helper function for left of the root. So helper function for root left, right? Helper function for root left. Now after this function will return, this call will return itself, and after that, just after that, call for right. Helper of root right, right? This is the only thing you have to do. Let me draw the recursion tree of it, and then you will be able to visualize that what is actually happening. So I will be using this space only, right? Okay. You made the first call for root. Let me write down the node as one value only. You made the first call for 1, right? This is f of 1. Now, first step is root is not equal to null, right? 1 is not equal to null. So I will be printing the 1 value. I print 1, right? After that, I am going towards root left. So one of the recursion call is for root left. What is the root left? It is 2. Another root left, and then after okay, so let me write it down separately afterwards. f of 2, right? After that, root left again, 2 will be printed. I print 2, again go towards left. So f of 4, because this recursion call only take place. After that, print 4. Is there, like, I will go towards the left of the 4, but it is null right now. It is null. So what will happen if root is not equal to null? It will run. But if root is equals to null, it will be running nothing, right? It is a void type of function because I'm actually printing. You can also add a statement that else return. If the root is null, you cannot do anything, so return, right? Okay, so 4 recursion call is not finished right now, because in the case of 4, I will be doing the right also. I will be go towards the null, I will go towards null again, and then I will return to 2. As soon as I return to 2, 2 will say that this line has been done. It is time for roots right. So I will go towards f of 5. F of 5 will do the same. N first print the 5, and then n. F of 2 has been explored. Moving to f of 1. Now f of 1 will call f of 3. 3 will be printed. Go towards 6 now because of this line, right? Go towards 6. Print 6. again n here, n here. Moving towards 7, f of 7, print 7, right, n, and the recursion tree is this much, which is actually very equals to the binary tree only. Okay, which is actually very equals to the binary tree, and you can see the pre-order we got is actually matching the above two, 1 2 4 5 3 6 7. That is the pre-order, that is the pre-order. So this is the recursion code. Helper root, if root is equals to null, is not equal to null, print the root value, go towards root left, and after that root left is returned, go towards the root right. This is the recursion code. So let me write down the recursion code first, then we will come back and we will see the iteration code also. So here is the lead code problem for giving me the pre-order traversal. I want, instead of printing it, I want to return it in an answer. So I will create a vector int answer, right? And I will create a helper function as well, helper function, and I will send my root here and my answer here. Why my answer? Because I want to print it, right? I want to return it, right? And then you can simply return your answer. Now because I want to fill the values into the answer, I will be sending it by reference. So void helper vector of int, oh sorry, tree node star first. So tree node star root with vector of int sent by reference and answer, that is sent by reference. Now what will happen? If my root is not equals to null, only then process. What do I do in that case? I will say explore the root first. For exploring the root first, I will be adding the answer value into the answer. So answer dot pushback root value. Now it is time for you to move towards left. So helper of root left and then helper of root right. That's all, right? And then you can just return. And now it is time for you to run the code. Hope it should run fine. It should not give any error because I think I've not committed any error. There is a problem. Oh, I have to send the answer again, right? Few arguments. Answer. Should run fine now. It is running fine for the sample test cases. Let's try it for submit as well. And please don't leave the video because we are going to discuss the iteration order also. Okay. It is running fine. So let us move towards the iteration order now. So here we are for the iterative approach, and let us try to code it down. So iterative approach only has a limitation that don't use recursion. Don't use recursion. What does it say? It says that root has been provided to you. Just use the for loops or any data structure you want, but don't use recursion. Now it says you can use any data structure. So what will I do? I know that recursion is actually similar to the stack. Recursion actually similar to the stack. So we're using the stack data structure. Okay. So now 1, 2, 3, 4, 5, 6, 7. It is foremost clear that I will be pushing the one value into the stack. Let me create a stack here. I push one value into the stack. I push one here. Right? Now, what will my code do? It will pop out the element. It will pop out the element. So one is actually now here. Right? Now, because the pre-order said explore left, right. So I will do the first step first, explore. Now I want to explore, what I will do, I will print it. Or I will add it to the answer, add anything you can do. Suppose I print it, I print 1, right? Now, 1 has a left, 1 has a right. My approach says that I want 2 first, I want 2 first and third second. These are the relative order, I want 2 first and third second. Now, stack has a property of reversing. Stack has a property of reversing. What do I mean by that? If I push 2 first and then 3, at the time of popping out, 3 will come out first. At the time of popping out, 3 will come out first, right? Because of the LIFO output, LIFO property. What is the LIFO property? That last in, first out. The element which has been inserted at the last in the stack will be the first one to emerge out. Okay, so if I put 3 first and 2 third second, then 3 will be first one to get out of the stack, right? Okay. Now what should I do to prevent that? I want 3 at second position. So what do I do is I push the right part first. That is push right first. Push right first. I push the right first. That is I have 3. Now I push 2. I push 2. And now you can see the relative order of 2 and 3 is exactly what I wanted. 2 will come out to first and then 3. So I already pushed out 1. Stack doesn't contain 1. I will pop out 2. I will pop out 2. And as soon as I pop out 2, 1, I already have written 1 here. I will write 2, right? And 2 has 2 nodes, 4 and 5. Again, push the right first. So 5 here, 4 here. Pop out 4. Pop out 4, write it down. write it down, right? 4 doesn't have a left or right, so I will not push it into it. I will pop out 5, I will write 5. 5 doesn't have a left or right, right? Okay. Now the element left is 3. I pop out 3. 3 has a left, 3 has a right. So what will I do? I will push out, I will push right first. I will push right first. So 7 comes here. 7 comes here. Oh, sorry. I will push right first. So 7 first, then 6, right? 7 first, then 6. Moving on. I will pop out 6 because 6 on the top of the stack. Then write down 6. 6 doesn't have a left, 6 doesn't have a right. 7. Pop out 7. 7 here. 7 doesn't have a left, 7 doesn't have a right. And that's all. You actually have your determined pre-order traversal. 1, 2, 4, 5, 3, 6, 7. Right? What is the code I am trying to use? What I do? I created a stack. The stack will contain my node. Right? After that, if root is not null, only then you can push. So stack dot push root in that case. Now what will I do? What will I do? I will say while my stack is not empty, that is still there are some nodes which are to be explored. What will I do? I will say node is equals to st dot pop, right? First thing you have to do is print node value. Print node value. Now, if it has a right child, if node has a right child, then push it. So st dot push nodes right. St dot push nodes right. Again, if node has a left value, st dot push nodes left. Nodes left. Right? This is the only thing you have to do. You printed it and now you can simply return, and this will actually give you the value you wanted. We actually discussed the dry run first only. That is this. This is the dry run actually. This is the dry run of the following code. Right? And now it is time for you to see the iterative approach code. And please, if any doubts are left with you, you know where to comment. I will surely get back to you within that scope of 24 hours. Okay. So moving on to the code now. So I'm not rubbing down the code of the helper function, right? I will be writing down the iterative approach below only, and the code you will get is will give you the both the codes you want, right? Okay. Now, what will I do? I will first create a stack. So stack of tree node star, tree node star, because it is containing tree node, right? Name it as st. Now, if my root is not null, in that case, st dot push the root. Now, what will happen? While my st is not empty, I have to do something. What do? I will say tree node star node equals to st dot top. Now you are free to pop it out. St dot pop. Now what will you do? You will say that first push it into the value. So answer dot push back node value. Now if node has a right, if node has a right, st dot push node right. If node has a left, st dot push node left. Right? These are the only operations you have to do, and now it is time for you to return the answer which has already been written down. Okay, so let us try to compile and run it. It should work fine, I guess. It should run fine. So it is running fine. Let us try it for submit as well. And it is running. Okay, accepted. So thank you for watching, and we'll meet tomorrow with a new video, with a new lecture. Please stay tuned. Okay, have a nice day.